9.2a. Hopefully this will be the easiest question on your test, but it does require some algebraic manipulation. Inverse Laplace transforms always do. So the most important thing to remember with an inverse Laplace transform is that it has to look exactly like it does on the table. So you can't say it's close enough. It needs to look exactly like it does on the table before you can apply that transform. So the first thing I'm going to do is I'm just going to split this up into two fractions. So instead of that, I'm going to find the inverse Laplace transform of 3s over s squared plus 9, and then plus 6 over s squared plus 9. Okay, and hopefully at this point you're thinking in terms of sines and cosines, because anytime you have a base that looks kind of like this, it should tell you that you're going to be dealing with sines and cosines. So first of all, it doesn't look exactly like what it needs to be. So in order to make a Laplace substitution, this needs to be a 3, and this term needs to be an s. So all we're going to do is we're going to factor out. So now I'm going to find 3 times the Laplace, well, the inverse Laplace transform of s over s squared, and then I'm going to go ahead and write 9 as 3 squared, and then plus 2 times the Laplace inverse of 3 over s squared plus 3 squared. So hopefully this is looking a lot more like your table entries. I do recommend getting really familiar with the tables and just kind of getting a better feel of how to use them before you try to use them on the test. So now that we have it written like this, hopefully it makes good sense, and it should look very much like your table entries. So this is the exact Laplace transform for cosine of 3t. And then we still have this 3 multiplier, so don't forget about it. We have 3 cosine 3t, and then plus 2, and this is the exact Laplace transform for sine of 3t. So hopefully that wasn't too bad, and it made good sense. So just to be thorough, I'm going to go ahead and rewrite the question, but hopefully that's not too bad. Like I said, if you get good at using the table, this should be the easiest question on your test, but I understand it can be confusing for some people, so please let me know if it's not making sense. I'd say the hardest part about this is the algebra. So just being able to see when to pull things out and stuff like that. So hopefully it goes okay. So I'm going to go ahead and get rid of this. And get 9.2. And get 9.2b up. Okay, today's not my day for using basic computer controls, but that's okay. Okay, so now we're going to do 9.2b. And with 9.2b, it's a very similar concept. So you're going to manipulate these algebraically until you can make it match something on your Laplace table. So we have the inverse Laplace transform of all that gobbledygook. So again, my first step, I'm going to split into 2 fractions. So I have the inverse Laplace transform for the square root of 2. That's an s. I don't know why I've been doing that. That's the second time this morning I saw an s and thought it was a 2. Square root of s over s times the square root of s, and then plus the inverse Laplace transform of 1 over s times the square root of s. Okay, so this one's actually better, in my opinion, because it's easier. This obviously cancels, so we get our inverse Laplace transform of 1 over s, and then plus our inverse Laplace transform of 1 over s times the square root of s. And I know the second term might look a little bit scary, but there's actually a table entry for it, so not too bad at all. So what we're going to conclude is that the Laplace inverse of the square root of s plus 1 divided by s square root of s equals, so the Laplace transform for 1 over s is just 1 once you look at your table. So we have 1 there, and then the Laplace transform for 1 over s times the square root of s is plus 2 times the square root of t over pi. And that's that whole question. So hopefully it makes good sense. Like I said, please practice using the tables. And then I will say before, I feel like people would ask me, this second term here has some different ways you can write it. You can write it however you want. If you don't want to rationalize the denominator, or you want to write it however, as long as it's mathematically equivalent to this, that's absolutely fine. So however you want to write that is fine, as long as it looks something like this or something equivalent.